Imagine a world where billions of everyday objects are not just passive items, but intelligent entities capable of sensing, communicating, and acting on their own. This is the vision of the Internet of Things, or IoT, where billions of objects with embedded intelligence connect over Internet Protocol networks. To understand how this works, consider the basic methodology. An IoT device is created by taking a thing, defined as anything besides a standard computer, and adding both computational intelligence and internet connectivity. Computational intelligence is typically achieved by embedding a processor or microcontroller inside the object to improve its functionality. Meanwhile, internet connectivity allows the device to utilize resources that are not stored locally, often serving as an interface to powerful cloud databases and servers. The evolution of everyday objects into IoT devices can be seen clearly in modern appliances and vehicles. A classical refrigerator simply keeps items cold with a decades old interface. An intelligent refrigerator adds features like alerting you when a door is ajar or suggesting recipes based on its contents. However, a true IoT refrigerator goes further, searching for the lowest food prices and ordering groceries automatically when you are low on supplies. Similarly, a 21st century car may contain 50 different processors for specialized tasks like fuel injection and anti lock braking. When networked, these cars become IoT devices that can be started remotely or automatically contact emergency services in the event of an accident. Even logistical operations like Amazon utilize IoT through RFID tags and scanners to maintain constant global tracking of packages. It is important to differentiate between a standard computer and an IoT device. A computer is a general purpose machine designed to run any code, whereas an IoT device is a special purpose thing where both hardware and software are optimized for a specific set of related tasks. The growth of these devices is supported by several major trends, including the drastically decreasing cost and size of hardware. For instance, while the ENIAC computer of 1945 weighed tons and filled a large room, modern laptops and tiny IoT sensors offer billions of times more computational ability. This is further enabled by ubiquitous wireless infrastructure and the ability for devices to interface with cloud services like Siri or Netflix to process complex queries. While the technical foundation of IoT involves specialized standards like Zigbee and Bluetooth BLE at the physical link layer and protocols like 6LoWPAN at the network layer, the social implications are equally significant. IoT aims to make life easier by increasing independence for older individuals through technologies like driverless cars and by enabling global interaction without the need for travel. However, these benefits come with substantial risks. High reliance on these systems means that network or power outages can be critical, even life-threatening for those with health-saving devices like heart pacemakers. Furthermore, pervasive connectivity raises major privacy and security issues, as location tracking, health data, and purchasing habits can be monitored or even hacked via cloud databases. Understanding these factors is essential as IoT continues to integrate into every aspect of our digital architecture. Subscribe to know more about such topics.